Austin?
Ma'am, the height?
Yeah. At the highest point. No, it's not a problem. Just
It's radius into 2.
uh, 2 times the radius, correct? So h becomes at the highest point, h becomes equal to
R.
2r. Is that correct?
Yes,
Austin,
ma'am.
is that correct? Okay, fine. So if h becomes equal to 2r, then what happens to the tension TH?
It half.
Huh? TH becomes equal to, just instead of h, you substitute as 2r. Even others keep doing it, boys. Calculate, and Austin, let me know, Austin.
Ma'am,
Hmm?
should we by heart these formulas?
No, no need, no need.
Okay,
I'll
ma'am.
tell you. I'll tell you which formula needs to be. You need to by heart so that you can solve your numerical. That's it. This
Okay,
is
ma'am.
only.
Ma'am, can you tell the answer?
Yeah, just tell.
Ma'am, m by r
Mhm.
into u square minus 5gr.
Correct. Boys, are others getting it, boys?
Yes, ma'am.
Yes, ma'am.
Right. So you have found the tension at the lowest point and the tension at the highest point. Now the question is, have you completed? I'll go for the next one, boys. Can I go for the next one? Jonathan?
Yes, ma'am. Ma'am, should we write the difference between them both also?
Not
They are not
necessary.
necessary.
No, not necessary. If they ask, you can go for it.
Okay, ma'am.
Now look at this. Minimum velocity of projection at the lowest point for looping the loop, which means there should not be any slackening of the string. You know what do you mean by slackening of the string? Your string should not be like this. Your string should be straight. It should hold a tension, right? So the minimum velocity of projection at the lowest point for looping the loop. So the body will be able to cross the highest point without slackening. Do you know what is slackening? Suppose if I take the highest point h, and the object reaches over here, its weight will also act in the same direction at the center. Tension will also. Now, suppose if you take a bucket full of water and whirl the bucket in a vertical circle, generally what happens when we whirl, water will naturally water will spill out. But if you whirl the bucket full of water with a certain velocity, keep this in mind, boys. If you whirl a bucket full of water with a certain minimum velocity, when the bucket reaches the highest point, there will be no water spilling out of it. Generally, what happens when you fill a bucket full of water and then say whirl it in a vertical circle, naturally there will be a spillage of water. But if you whirl a bucket full of water with a certain velocity, what we call it as minimum velocity, then when the bucket reaches the highest point, still water will not spill out. What is that minimum velocity? They're asking you. So for that, the condition is that the body will be able to cross the highest point without slackening. Here, since we are not considering the motion of a bucket filled with water, we are just considering the motion of a stone which is tied to a string. So the string should not slacken. For that, they are stating that your TH should be positive. This is the condition. The tension along the string at the highest point should be positive. So when it can be positive only when the value is greater than or equal to 0. So what is that we have found for TH, boys? What is that we have found for TH? TH is m by r into u squared minus 5gr. What was the expression for TH?
Yes, ma'am.
Yes, ma'am.
M by r into u squared. So that should be greater than or equal to 0. Now m by r. Now why does m by r vanishes in the next statement? Can someone answer? Why does m by r vanishes in the statement?
Ma'am, multiplied by 0. I mean divided.
No, because they're always positive.
Yeah.
Oh,
Mass
sorry.
and yeah, correct. Mass and radius. Can this be equal to 0? Look at this expression. Look at this sign. Greater than or equal to 0. See, m by r, if I use the first equality, suppose m by r is greater than 0, this is fine. M by r can be greater than 0, but can m by r equal to 0? Is that possible? You cannot have a body of mass m and the radius of the path is also 0. Can that happen? That cannot happen. That is why u squared minus 5gr can be greater than or equal to 0. That is the reason you have gone for this, right? So u should be greater than or equal to root 5gr. So what is u? U is the minimum velocity with which you have to whirl the stone so that at the highest point reached, there is no slackening of the string. Boys, have you completed?
Ma'am, we doing any numerical with these formulae?
And here someone, yes, wait 1 second. Someone was asking which formula you should by heart. You can by heart this. U is greater than, yeah. The other things you have to derive. This is what you need to buy. U is greater than or equal to root 5gr.
Okay, ma'am.
Boys, copy down, boys, and you go through this at home so that I can proceed with at least one numerical, and I'll start with a system of particles and rotational motion. That chapter is one of the toughest in your 11th grade. It takes time for us to complete. So just be a bit fast. Just go home and redo this.
Ma'am?
Yes?
Why is m by r like removed from the equation?
Okay. What is the condition, boys? Sorry. Can m by r can be greater than 0. That's fine. Sorry. M by r cannot be equal to 0. Can m by r be equal to 0? Is that possible, boys? Can your
No.
mass?
No, ma'am.
That's the reason you are removing that. You're not considering. You're only considering u squared
Okay,
minus
ma'am.
5. For you, 11B, physics is tough, right? Or the volume is more compared to other subject.
Yes, ma'am.
Volume is more.
Yes, ma'am.
Theory itself is taking so much of time. I don't know how I'll complete the numerical part. Shall I move for the next one? Please, once you have completed, just ensure that I can move for the next one. The last topic of this, right? If someone needs to copy, just take a screenshot and put it in the chat box. Okay. Minimum
Ma'am, what's
velocity.
the next chapter?
Next chapter, system of particles and rotational motion.
Okay, ma'am.
Fine, boys. Minimum velocity of the particle when it reaches the highest point. Boys, when it reaches the highest point, let us differentiate the velocity. Let the velocity be equal to capital V. And at what height? The height of h, this height is 2r, right? So the question is, what should be the minimum velocity at the top so that the water, I'm just considering the case of whirling a bucket full of water at point H. When the bucket reaches point H, there should not be any spilling of water. So what should be the minimum velocity with which the bucket should be have a velocity at point H? So what was your expression was previously? V squared, the velocity at any point. What is the velocity at any point? V squared is equal to U squared minus 2gh. The velocity of a body at any point, the general expression is V squared is equal to U squared minus 2gh. Now we are considering the velocity at the highest point. Your V becomes capital V, U is the same, only difference is the height becomes 2r. So capital V squared is equal to 4gr. Now, what was u in the previous case? What is the value of u in the previous case was? Root of 5gr? Yes or no? Was
Yes, ma'am.
if you want to whirl a bucket full of water so that there is no spilling of water, then the minimum velocity at the lowermost point is u. The maximum, so minimum velocity at the highest point is capital V. So what was u? Minimum velocity at point L. It was 5gr. U was root of 5gr. U squared becomes equal to 5gr minus 4gr. So this should be the minimum velocity or the critical velocity at the highest point. So at the highest point, the critical velocity should be gr. These two things you can by heart. U is equal to root 5gr. The minimum velocity at the lowermost point should be root 5gr. The minimum velocity at the highest point should be equal to root gr. These two expressions you can by heart. Copy down, boys.
Ma'am, should we by heart the tension formula?
No need. No need.
Okay, ma'am.
Shall I move for the next? I'll do a numerical and then I'll start with the next chapter, boys. Shall I go for
Okay,
it?
ma'am.
I think only Prasanna is there in the class. Is that so? Dheeraj?
Yes, ma'am.
Dheeraj, and I'll call you. Only these boys will be answering now. Whether I have to go for the next chapter, next slide. I want Dheeraj and Ayan. Right, boys? That's why I'm just reading it out. This is a textbook numerical, boys. Two identical ball bearings in contact with each other and resting on a frictionless table, which means you have two ball bearings, 2 and 3, right? Marked as 2 and 3. Now these are in contact. Do you understand, boys? Two identical ball bearings, which means their mass are going to be the same. They are in contact and they are on a frictionless table. Clear? And then it is hit by another ball bearing of the same mass, which means all the three are going to have a mass, same mass. But the ball bearing 2 and 3 are at rest. one is moving with a velocity. The first one is moving with a velocity and hits the second and third, which are in contact. Are you clear with the question? Are you clear with the question, boys? Ayan, are you clear with the question? Okay. Now, after collision, there are three cases given. Boys, please understand. This is before collision. Before collision, and there are three cases given after collision. So after collision, this is what is happening. Now, you have to check whether case 1, case 2, and case 3, which scenario is going to be valid if the collision is elastic. If the collision is elastic, which is a valid one? Kritya?
Yes, ma'am.
If I want to check whether the collision is said to be elastic, what should be the condition?
Ma'am, like the velocity of separation by velocity of approach, relative velocity.
Okay, that is fine.
P1,
That is
right?
okay, correct. That is one way of stating. If the collision has to be elastic, boys, the kinetic energy before collision must be equal to kinetic energy after collision. Is that clear?
Yes, ma'am.
So, right, boys. According to conservation of energy, please do write conservation of kinetic energy. According to the conservation of kinetic energy, total kinetic energy before collision must be equal to total kinetic energy after collision.
Ma'am, is there a question number we can write?
I think so. 0.16, boys.
Okay, ma'am. Thank you.
It's textbook question. So the total kinetic energy before collision must be equal to total kinetic energy after collision. For what? For the collision to be elastic. If the collision has to be elastic, elastic means there is no loss of energy. For the collision to be elastic, what is the condition? Total kinetic energy before collision must be equal to total kinetic energy after collision. Is that clear, boys? Is that clear?
Yes, ma'am.
Okay. Surya?
Yes, ma'am. Yes, ma'am.
Surya, let us calculate the total kinetic energy before collision. Okay.
Yes,
So
ma'am.
now we have to add the kinetic energy of particle 1, 2, and 3. What is the kinetic energy of particle 1? See, before collision.
Ma'am, 1/2 mu square.
Okay, half m v squared. Okay,
U
fine. No, here.
Ma'am, before collision, right?
Yeah.
Initial
But here,
velocity. So.
no, but the initial velocity is given as v. Can you see the diagram?
Okay. Yes, ma'am. Yes, ma'am.
Okay.
Yeah, I see.
What will be the kinetic energy of particle 2?
Ma'am, half m1 v square. Was it the same masses?
No, correct. But look at the condition. Can you see resting? 2 and 3 are at rest. So what will be
So
the
then it'll be 0, 0. Kinetic energy will be 0, 0.
Okay, fine. So what will be the total kinetic energy before collision then?
Ma'am, 1/2 mv square.
Okay, fine. So I'll write this total kinetic energy. That will be equal to what? Half m v squared. Do others understand? Boys? Okay, fine. So this is before collision. So before collision, what is the total kinetic energy, boys? Okay, total kinetic energy will be equal to half mv squared. Okay. Now we'll go for, this is after collision. The first case. After collision, I have to find total kinetic energy. Okay, fine. I'll call you Jatin. Jatin. Was a big,
Yes, ma'am.
Okay. What will be the total kinetic energy after collision for case 1? Okay. After collision, I have encircled. Should I encircle in red? Okay. In this case, after collision, particle 1 comes to rest. Particle 2 and 3 are going to combine together and move with a velocity v by 2. Can you understand the scenario over there, Jatin? Is that clear?
Yes, ma'am. So
After collision, first particle comes to rest. 2 and 3 are still sticking together and moving as a single one. Okay. So what will be the kinetic energy of particle 1 after collision?
it will be 0 since
Okay,
it's not
fine,
moving.
0. Now 2 and 3 are combining and moving. So what will be the total mass? Okay. What is the formula for kinetic energy? Half m into v squared. Kinetic energy general formula is here. What is the mass, boys? Both 2 and 3 are combining. So what is the mass? M plus m?
2m. Yeah. Oh.
Okay. M. Are you clear? Jatin, are you clear?
Yes, ma'am. Yes, ma'am. I got it.
Both are combining together and moving. M plus
Yeah.
m. With what velocity they are moving?
V by 2.
So then it is v by 2 the whole
The
square.
whole square. Yeah.
Okay. Now what is that you are going to get? This is 2m, correct?
Yeah.
And this is v squared by
V
4.
squared by 4.
Okay. So what is the final expression? It is mv squared by 4.
Yes, ma'am. Yeah.
Sorry. But look, before collision, what is your kinetic energy? Total kinetic energy before collision, Jatin? Before collision, what is the total kinetic energy, Jatin?
It's
Half
half
mv.
mv square. Yeah.
After collision, in case 1, what is the total kinetic energy?
mv square by 4.
Are they matching?
No,
No,
they are
ma'am.
not.
Which means the case 1 is inelastic. Okay. Case 1 will be inelastic. So that is not going to match. Okay, Jatin has completed this. I want, who's this?
Ma'am,
Maheshwar.
I think it's case 2. The
Okay,
correct
case
answer.
2. Okay, fine. Let us find. Shamshul. Okay, I'll go for. Can we do for case 2? Can we do for case 2? Kavin. Why it's the technology is at the peak? Why you people take so much of time to respond? Kavin is here. Okay, Steve.
Yes, ma'am.
Okay. For case 2. Okay, what will be the kinetic energy of particle 1 for case 2? Is particle 1 is at rest?
Ma'am, in case 2, yes, ma'am, V is equal to 0.
Okay. Particle 2.
And particle 2 also, I think V is equal to 0.
Okay. Particle 3.
And particle 3, V. 1 by 2, yeah, 1 by 2 mv square.
Okay. So now, does this total energy matches with this one?
Yes, ma'am, it does.
Okay. So which means the second one is an elastic collision.
Yes, ma'am.
Okay. Third one, try to do by yourself, boss. I'm taking a lot of time. Just complete this. I'll start the next chapter.
Ma'am, third one is not possible.
Okay.
Hello, ma'am.
Yeah, what happened?
Ma'am, this is Kavin. Yeah, I took time to unmute because my laptop it's very
Okay.
slow right
Who is
now.
that? Who is that?
Ma'am, it's Kavin.
Okay. It's okay. But someone can put the screenshot in your chat box so that I can move.
Ma'am,
Yes.
is it necessary to show all the cases? Like if the
Not-
case is correct, then you can end up with that, right?
Yeah. Can you see the marking scheme?
Okay, ma'am, got it.
Half. It's a 2-mark question. Half.
So you lose half mark if you don't write
Yeah,
the case
that's
3.
Yes, boss. That's the thing. Can you see the marking scheme?
Ma'am, in the third one, why did they combine all the masses?
Where are the masses combined?
Like, yeah.
2 and 3 are being combined. So these are the scenarios they have given. Can happen.
Okay, but one will still be separate, right? In the third case.
Yeah, correct. One will be at rest. It's not moving. Only 2 and 3 combines and moves.
Ma'am, then it's supposed to be 2m, right?
Sorry. Okay. Sorry, boys. As per the diagram, it looks different. Sorry, boys. Then in that case,
No, okay, ma'am.
no. Even in that case, that will be a problem, boys. No, this is going to be a problem. If you put like in this case, if I do like this, but it doesn't look 2 and 3, 1, 2, 3 are being combined anyway. One. No, should I do this the last part? You can do by yourself, boys. See, the first one is also moving. Second and third are moving together. Anyway, you can combine and do. Okay, let me try. So the third case, I'm talking about third case, it is half mv square, sorry, v by 3 the whole square, plus now the next is both are going to combine, 2 and 3 are combining with a velocity v by 3 the whole square. Now what is common here? Half v by 3 the whole square is common, so then m plus m plus m, so that becomes 3m. Correct? Is that fine, boss?
Yes, ma'am.
Three numericals to be done, boys. One more is there, but I don't know. I'll start with this one.
No, ma'am, the previous question. Okay, ma'am. Thank you.
Can you put this in the chat box, boys? Just try to do, or should I explain you the next one?
I'm just did like in the chat.
Explain. Okay. Fine. Now look at this, boys. You have a wooden block. That is what the question means, okay, right? This is your wooden box now, or a wooden block. Now this wooden block is tied to a string which is attached to a ceiling. So which means your wooden block is suspended freely. Now you have a bullet which is moving at a speed of 400 meters per second. Right? It collides with the wooden block, and finally the bullet comes out of it. Right? The bullet is going to pass through the wooden block and emerges out of the wooden block. Now, while the bullet is passing through the wooden block, it transfers some energy to the wooden block. Wooden block was initially at rest. So now what is happening is that now the wooden block is gaining some velocity and it moves to a position. So initially it was.
Ma'am, isn't it break?
Okay. Check the time in case if it is happening.
Thank you, ma'am.
Thank you, boss. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, boss. So,
Can you explain this
Thank you,
question
ma'am.
again? Next class.
sorry, next class.
Yes, thank you.
Thank you, ma'am.
Thank you, ma'am.